Inner Mongolia, China, about 70 million years ago. The surrounding environment was characterized by high humidity, a vast braided river valley complete with floodplains. The presence of caliche-based sedimentation suggests a semi-arid climate. This area boasted lush vegetation and abundant foliage. Additionally, the floodplain systems were home to a diverse array of algae and crustaceans. Archaeornithomimus, an omnivorous ornithomimid. In the 1920s, an expedition by the American Museum of Natural History to Inner Mongolia uncovered a wealth of theropod fossils across 3 different quarries. The findings included mostly disarticulated remains from several individuals, although skull and lower jaw materials were notably absent. In 1933, these remains were briefly described and classified as a new species of Ornithomimus. Later, in 1972, the species was reassigned to a new genus, Archaeornithomimus, which then became the type species for that genus. At the time, it was recognized as one of the oldest known ornithomimids. Archaeornithomimus was a medium-sized ornithomimid, measuring about 11 feet in length and weighing more than 158 pounds. Strong evidence from its ornithomimid relatives indicates that Archaeornithomimus was likely covered in feathers resembling those of modern birds, and it sported a beak made of keratin. The hind limbs exhibited a sturdy construction. The upper end of the third metatarsal was not constricted. The cervical vertebrae displayed significant pneumatization, characterized by intricate internal chambers within the neural arches and the vertebral body, suggesting the existence of cervical air sacs. While the anterior dorsal and certain caudal vertebrae showed some level of pneumacity, the sacral vertebrae remained devoid of air spaces. In a study carried out in 2001 by paleontologists, 229-foot bones attributed to Archaeornithomimus were analyzed for indications of stress fractures, but none were detected. Archaeornithomimus fossils have been found in China, Kyrgyzstan, and Uzbekistan. Archaeornithomimus derives its name from ornithomimus, paired with the Greek word archaeos, which translates to ancient. This nomenclature reflects the belief that Archaeornithomimus dates back to the late Cretaceous period. Archaeornithomimus, similar to its ornithomimid relatives, was probably an omnivore with a tough beak, consuming a diverse diet that included small mammals, various plants and fruits, eggs, and even the young of other dinosaurs from late Cretaceous Asia. Across the river, Gigantoraptor, an omnivorous oviraptorid. Gigantoraptor stands out as the largest oviraptor for which we have skeletal remains. This remarkable creature is estimated to be about 3 times longer and 35 times heavier than the previously largest known species, Citipati. Gigantoraptor is believed to reach lengths of around 26 feet and stand 11 feet tall at the hips, weighing in at a hefty 1.5 short tons. Some research suggests its body mass could be even greater, possibly exceeding 2.2 short tons. In 2017, researchers examined the jaws of Gigantoraptor and found it had the deepest beak among synagnathids, indicating a diet distinct from other oviraptorosaurs. The jaw's articular region resembled that of the modern tuatara, suggesting a similar feeding technique with unique forward and backward movement. This, combined with sharp dentary edges, implies a shearing bite capable of slicing through both plant material and possibly meat. The depth of its lower jaw suggests a large tongue that may have aided in food processing. Gigantoraptor's U-shaped dentary indicates it was likely a non-selective feeder, advantageous in fluctuating environments, supported by comparisons with various herbivorous species. Its broad, rounded rostrum aligns with a generalist diet, unlike the narrow rostra of selective feeders. Its large size may have led to a preference for lower quality, abundant food, though it remains unclear if its digestive system could handle such intake. The research team also considered the possibility of an occasional carnivorous diet, as its robust beak and jaw movement could facilitate meat processing. Researchers have proposed that Gigantoraptor may have been somewhat naked due to its massive weight, which is about 300 times heavier than feathered species such as Caudipteryx. Larger animals often depend more on their body mass for temperature control, which can lead to a reduction in the insulating feathers seen in their smaller counterparts. Nevertheless, they believe that Gigantoraptor likely retained feathers on its arms, as these feathers serve important roles in display behaviors and protecting eggs during brooding, functions that are not directly tied to temperature regulation. Oviraptorids are widely acknowledged for their feathered characteristics, as shown by feathered specimens like Caudipteryx and various oviraptorids. While Gigantoraptor was probably feathered as well, its significant size may have contributed to it being partially devoid of feathers. Gigantoraptor fossils have been found in Inner Mongolia, China, in the Erlian Basin. The lower jaws, as they have been preserved, measure a total length of 460 millimeters and lack teeth. This structure has fused into a broad, shovel-like form, suggesting that the unidentified skull was over half a meter long and also toothless, likely featuring a horny beak. The left side of the jaws is particularly well preserved, maintaining an almost complete shape, in contrast to the right side. The dentary bones are notably deep and devoid of teeth, showcasing a pair of sharply defined shelves along the upper edges. These features are relatively flat. The front end of the dentary is rounded, which differs from the chin-shaped appearance found in some oviraptorids. The name Gigantoraptor comes from the Latin words gigas and gigantis, which translate to giant, combined with raptor, meaning Caesar. The specific name Erlianensis is linked to the Erlian Basin, the location where the fossils were discovered. The Gigantoraptors have recently traveled from a dry, arid area where both food and water were hard to come by. After a long and exhausting journey to the vibrant floodplains, they are now hungry and searching for a swift meal. Luckily, they have spotted a group of Archaeornithomimus on the opposite bank of the river. The problem isn't the swift current of the river, it's the depth that poses a challenge. They need to locate a series of rocks to leap across, ensuring they don't slip and plunge into the water while pursuing their targets. Crossing the river was a breeze, but the real challenge lies in pursuing the fleeing flock of Archaeornithomimus. After pulling their catch onto the shore to prevent it from being swept away by the current and devoured by fish, the Gigantoraptors have secured a feast. The Gigantoraptors are about to embark on their hunt, motivated by their insatiable hunger. They find it much more effective to see several easy targets in a single location and establish caches, rather than waste energy on prolonged chases through the forests, which ultimately depletes more energy than they gain. the Archaeornithomimus group scurries away in terror, having realized the dangers of lingering too long in the open.